Hey guys, we're going to go pretty fast here today. Today we're talking about the applications of and solutions with substitution. So we're basically just solving systems of equations. Now you can solve this with substitution or you can solve these with elimination. It really doesn't matter. The important thing is that we know how to solve them, okay? And whenever you see the word applications, think word problems, think more advanced type of questions, because that's what we're doing today. So before we get too far, we need to talk about the three different types of answers we can get to a system of equations. If it graphs right there in the center and we find a solution, that's one solution. If they stack on top of each other, well, they're just the same equation, so that's infinitely many. And if there is no solution, that's where they're parallel, they never touch, there actually is no solution to that, and so we just end up saying no solution. So how do you recognize those whenever you're solving these algebraically? When you don't have the graph to look at, how do you see that? Well, we're going to take a look at a couple examples here, down here. So let's start here on number one. So number one, I'm going to solve this using substitution, okay? It doesn't matter, I could have solved this using elimination, but I'm going to solve this using substitution. So to solve this with substitution, we're going to have y equals 1/4 x minus 1, and I'm going to have on the other side negative x plus 4y equals negative 4. I'm going to draw my little squiggle down there, keep us separated. Now, just like with substitution, I'm going to take this 1/4 x minus 1, and I'm going to plug it in for y over on the other side. Okay? We're going to end up with negative x plus 4 times 1/4 x minus 1 equals negative 4. Okay? So I've just replaced that y with what was over here. I put parentheses around it to protect it. Now I need to distribute that 4, so we're going to distribute that 4 to both of these. I'm going to get negative x plus 4 times 1/4 is 1. So we're going to get 1x minus 4 equals negative 4. Now I want you to see what happens here. We're going to end up with negative x plus x. Well, negative x plus x makes 0x. So whenever I combine those two, they essentially just go away. And all I'm left with is negative 4 equals negative 4. Well, guys, here is how you know if you're going to get infinitely many solutions or no solutions. If you get to a part of your equation that doesn't have an x value, it's going to be one or the other. And then you just have to look and see. This one, we have negative 4 equals negative 4. If it's true, it's infinitely many solutions. If it's not true, it's no solution. Well, this one is true, right? That one is true, and so my answer is going to be infinitely many solutions. Okay? Infinitely many solutions. And that'll be my answer there. Okay? All right. So that's how we know if it's infinitely many. How do we know if it is no solution? So let's take this next problem here. We're going to do the same thing. I'm going to rewrite this, but I want you to pay attention to how I rewrite this here. I'm going to have y minus 2x equals negative 1, squiggle. Then we've got negative 2x plus y equals 2. Okay, I'm going to solve this one using elimination. All right, so we can see both options here. So if I solve this one using elimination, what I'm going to do first is we've got to make sure my x's, my y's, my equal, my whole numbers all line up. And if you notice this here, that x and y, they're flipped. Well, we can just rearrange that and we can rewrite it as negative 2x plus y equals negative 1. All right, and then I want you to look at this. Look at this real quick. Oh my goodness. We're left with, we want something to match. So if I have this negative 2x and this negative 2x, well, we have the same number, but I just want one of them to be positive. That way when I add my equations together to eliminate, one of those x's eliminates out. So I can change this one to be positive 2x. But if I change that to be positive 2x, I need to multiply by negative 1, just like what we did yesterday. So that makes positive 2x, negative y. Oops. So positive 2x, negative y, and positive 1. And then now what I can do is I can take this whole equation And I can write it underneath here. I can write negative 2x minus y equals 1, and I can add these together. All right, with negative 2x plus 2x, hey, that's nothing. That's 0. Oh, y plus negative y, that's nothing. So all I have left here on the left side is 0. What about the right side? 2 plus 1 is 3. Oh my gosh, all of my variables canceled out. So remember, if all of your variables cancel out, that is a very good sign that it's going to be no solution or infinitely many solutions. But look at this. Does 0 actually equal 3? No, that is not true. So if everything cancels out and it equals, it's infinitely many solutions. If everything cancels out and it doesn't equal, it's no solution. So that's what's going to happen here. This one is no solution. Okay, now let's turn the page and let's take a look at number 3. Number 3, it says, this is 8 word problems. This is our very first word problem. So I'm going to be trying to teach you some skills to be able to break this down and to break down these word problems. Looking at number 3, it says, at Manny's Taco Shop, you get an order of chips and 2 tacos for $9.25. The cost for 2 orders of chips and 5 tacos is $21.75. What is the cost of an order of chips? Well, we got 2 things, 2 unknowns. We have chips and tacos. So the first thing you always want to find out is, what don't I know? What am I looking for? And here we're looking for chips and tacos. So I'm going to say we're going to use C to represent chips, and I'm going to use T to represent tacos. And then we can just solve this just like we've done our previous problems. So let's read through this. It says you can get an order of chips, so 1 chips plus 2 tacos for $9.25. Okay? Then the cost for, okay, so here's my other equation, 2 orders of chips and 5 tacos is $21.75. Okay, guys, now that we're looking at this, we need to decide, do we want to use substitution or do we want to use elimination? It really doesn't matter. You can use either one. Either one is great. Here, I'm going to go ahead and use substitution. Not really that it matters, but I'm just going to go ahead and use substitution on this problem. Okay? All right, so to use substitution, we have to isolate one of my variables. So I'm going to isolate this C, and we're going to get C equals negative 2t plus $9.25. Okay, that's always our first step in substitution. If there wasn't an easy thing to solve for, I would definitely do elimination. But we're able to solve for that C very easily. So now I can take that value for C, I can plug it in for C over here. And I can get 2 times negative 2t plus $9.25 plus 5t equals $2.75. Okay, now let me scroll down so my screen doesn't get in the way. Now we just distribute. We're going to go 2 times both of these. 2 times negative 2 is negative 4t. 2 times 925 is going to be 1850. All right, then we're going to combine like terms. Negative 4t and 5t can combine and make 1t. So we're going to get t plus $18.50 equals $2.75. Okay. Then, oh, sheesh, guys. I wonder where I messed up. Look at this. That should be 21, 21, 21, not $2. Oh, good grief. All right, well, that makes this make a lot more sense. Because now, whenever I minus 1850, I'm no longer getting a negative. We're getting our actual answer. And we're going to get, how much does a taco cost? A taco costs $3.25. Must be a good taco to cost $3, right? So, taco is $3.25. But look at what my question is asking me. It's asking me, what is the cost of an order of chips? So, what I need to do is I need to take that value for t and plug it back in for t over here. And so we're going to get C equals -2 times $3.25 plus $9.25. Well, -2 times that's going to be -650 plus $9.25. We're going to end up with an order of chips costs $2.75. Okay, so order of chips is chips are $2.75. Perfect. All right, let's move on to number 4. So number 4 here says Mark has $4.95 in quarters and dimes. He has 3 times as many dimes as quarters. Write a system of any equations that can be used to find Q, the number of quarters, and D, the number of dimes that Mark has. Okay, now, $4.95 in quarters and dimes. So that means we've got to remember, we're going to use D to represent dimes. I'm going to use Q to represent quarters. Okay? Then, you have to remember how much these are worth. Each dime is 10 cents. We've got 10 cents for each dime, plus 25 cents for each quarter, and that equals in total $4.95. Then it tells me he has 3 times as many dimes as quarters. So which one does he have more of? He has this many dimes, this many quarters. How much more? 3 times as much. So I'm going to need to multiply my quarters times 3 to equal the number of dimes. So we're going to go dimes equals 3 times the number of quarters. Okay? So here are my 2 equations. Now I can take this value for D and plug it in for D over here. So I can replace that with 3Q. So we're going to go 0.10 times 3Q plus 0.25Q equals $4.95. Now, don't let the decimal scare you. 10 cents times 3 is going to be 0.30Q plus 0.25Q equals $4.95. Add these together, we're going to get 0.55Q equals $4.95. And then divide both sides by 0.55, and we end up with, how many quarters do I have? I end up with 9 quarters. It's kind of symmetrical there, isn't it? Okay, so I have 9 quarters, but once again, it's asking me for the number of dimes. So all I need to do is take that 9, plug it in for my Q over here, and we're going to say, okay, dimes is going to equal 3 times the number of quarters. So how many dimes am I going to have? I'm going to have 27 dimes. All right, there we go. Okay, then let's ask ourselves these questions real quick. It says your friend is solving an equation and our last line of work is 2 equals 2. What does that mean? It means that we have infinitely many solutions. So if it's true, that's infinitely many. If it is not true, like this 2 equals -1, that means that it is no solution. Okay? Just like that. All right, let's take a look now at our last 2 problems. So we have number 5, number 6, and then we'll save number 7 for later. So number 5, it says, you and your friend go to Tacos Galore for lunch. You order 3 soft tacos and 3 burritos. Okay, so we got tacos and burritos, right? So we're going to go T represents tacos, B represents burritos. Okay, so got tacos and burritos. So it says 3 tacos and 3 burritos equals $11.25. Okay, And it says your friend's bill is $10 for 4 tacos and 2 burritos equals $10. All right, now guys, listening. Whenever I see equations like this, where it's not super easy to solve for one thing, I just want to use elimination. Elimination is so much easier whenever it's represented like this. So on this problem, I'm going to use elimination. Okay? And so to eliminate here, I am going to, first, I'm going to have to match these up. So I want to match up this 3b and this 2b. To do that, 3 and 2 both go into 6. So I want this to be positive 6b, and I want this to be negative 6b. So now I have to think about what I'm going to multiply to do this. So here, I'm going to multiply by negative 2, by negative 2, and by negative 2. So 3 times negative 2 is negative 6t. 1125 times negative 2 is going to be negative 22.5. And then over here, I multiplied here by, oh, good grief, guys. I was multiplying over all of this by negative. That's just all wrong, isn't it? Okay? I should have been multiplying everything by positive 2. So let me restart this real quick. Okay. So I'm going to multiply. I still want this to be positive 6b, so I need to multiply by positive 2 to all of this. Okay? All right. So if I multiply by positive 2, that's going to be positive 6t, and that's going to be positive 2250, or 22.5. Over here, this is where we're going to multiply by negative 3. Okay? So I'm going to multiply this by negative 3, and this by negative 3, and this by negative 3. So that's going to become negative 12t equals negative 30. All right, awesome stuff. Now, all I need to do is take this part right here and write it underneath this. So that way I can combine those. So we'll have negative 12t minus 6b equals negative 30. Now, if I add these up, look what happens. If I add these together, we're going to get negative 6t here. Those in the middle are going to cancel. And then 22.5 plus negative 30 is going to be negative 7.5. Okay? All right, and then all I need to do is divide both sides by negative 6. So we're going to go negative 7.5 divided by negative 6, and we're going to get each taco cost $1.25. So it's going to be $1.25 per taco. So this must be at a different taco place than the previous side. This might be a cheaper taco than what we were getting over there for $3. So anyways, tacos are $1.25. But now I need to figure out what burritos are. So once again, we're going to start back at my original equation. We're going to go 4 times each taco. And 4 times $1.25 is going to be 5. So we'll get 5 plus 2b equals 10. Minus 5 to both sides, we get 2b equals 5. Divide both sides by 2, and we can get each burrito is going to be $2.50. Okay? So that's what we end up with. Each taco is $1.25. Each burrito is $2.50. Okay? All right, good stuff. All right, this is going to be our last problem here, number 6. At Pastime Diner, the cost of 2 pancakes and a cup of coffee is $3. So, pancakes, we're going to use P. Coffee, we're going to use C. Okay? And then the cost for 3 pancakes, and so cost for 2 pancakes and 1 cup of coffee is $3. And the cost for 3 pancakes and 2 cups of coffee is $5.25. Okay, this is another great example of a time where I want to use elimination. I'm just going to change this into negative 2c, so I'm going to multiply everything by negative 2. Why do I want that to be negative 2c? Because I want to cancel it out with that one. So this will become negative 4p minus 2c equals negative 6. And then I'm going to take this out, and I'm going to rewrite it right underneath here. And I'm going to have negative 4p minus 2c equals negative 6. Then I can add these two together. We're going to get negative p. These cancel, equals negative 1.25. No, sorry, negative 0.75. Okay. Then divide both sides by negative 1, and I end up with p equals 0.75. So each pancake is 75 cents. So what does that mean for my cups of coffee? Well, let's see here. Let's go back to my original equation. We'll go 2 times 0.75 for my pancakes, plus c equals 3. That's going to be $1.50. If I minus $1.50 to both sides, we're going to end up with a cup of coffee equals $1.50. Okay? So each pancake is 75 cents. Each cup of coffee is $1.50. Okay, let's go ahead and finish this out. Let's take a look here at number 7. Number 7 says there are 2 mystery numbers. The sum of 4 times the first number and 2 times the second number is 12. So 4 times the first number, so we got 2 mystery numbers. That's x and y. Okay? The sum of 4, so sum means add. So the sum of 4 times the first number and 2 times the second number is 12. And then my other equation, the sum of, so that's add, 3 times the first number and 2 times the second number is 8. What are the 2 numbers? Well, guys, this one couldn't be easier. Check this out. We have a 2 here. I can change that to a negative 2. If I change that, that's going to be negative 4x, negative 12. Then I can just take this, rewrite it right here. And we'll go negative 4x minus 2y equals negative 12. I can just add these real quick. Those will cancel. We'll get negative x equals negative 4. Divide both sides by negative 1, and we get x equals positive 4. I can take that, plug it back into my original equation for x. So we get 4 times 4 plus 2y equals 12. 4 times 4 is 16. Minus 16 to both sides. We will get 2y equals negative 4. Divide both sides by negative 2. By 2, not negative 2. And we're going to get y equals negative 2. And those will be my 2 answers for this problem. So, same thing we have been working on, we just have to interpret some word problems, but you can do it. All right, thanks guys. I hope you have a great rest of your day.